So we'll do the locus question. So we have two given points. If it helps, plot those 2 points. So 1 and 4 is A, and the other one is -3 and 2. And P is just a point on the number plane, say P is here. Call P x, y, x and y because they're both variables. And we want to find the locus, or the path P takes, so that its distance from A and its distance from B are always the same. So that's what equidistances, the two distances are the same. So what we want, this is the first one, what we want to prove is we're going to use algebra to prove that PA is equal to PB. That's what we want to show to find the locus. So remember, we use the distance rule. So that's x2 minus x1 all squared plus y2 minus y1 all squared. And that's our distance. So that's our distance rule. Except because there's a square root, what did I tell you to do to make it easier? Yeah, to square the distance. So instead of just PA equals to PB, it would be better if we do PA squared equals to PB squared. And that just actually eliminates the square root, and we'll just have to analyse what's inside. So I'm going to make P coordinates of P x2, y2, and all these are going to be x1, y1. And the reason why I actually want to make coordinates of P x2, y2 is because I want to make x and y the starting or the leading point. So we'll start with PA. So PA is x2, which is just x, minus x1, which is 1, all squared, plus y2, which is just y, minus y1, which is 4, all squared. And that's going to equal to PB, which is x minus -3. So what happens when you have a negative? What happens when you subtract a negative? It comes up positive. X2 plus y minus 2 all squared. So that's our equation. And now we expand. So this is just the distance equation. So we're going to expand these two. So x squared minus 2x plus 1, y squared minus 8x plus 16 equals to x squared plus 6x plus 9 plus 12 squared minus 4y plus y squared minus 4y plus 4. Right, so now we're going to collect like terms. So this question here, our x squareds are common on both sides, so we can cancel them. And so our y squareds are common on both sides, we can cancel them. And now I'm going to move all the x's to one side, so this becomes negative 8x. This one becomes negative 4y. And then we're going to add the whole number. So 1 plus 16 is 17. 17 take away 9 is 8. 8 take away 4 is plus 4. So this is our equation. And I always like, it's always good practice to simplify. So simplifying that. Is it minus 4 or is it plus 4?
Plus 4.
I thought it was plus 4. Okay. On this side you have 1 plus 16 is 17. On this side you have 17. And on this side you have 9 and 4, which is 13. You take the 13 to the other side, it's positive 4. Alright, so it's always good practice to simplify this, so we divide everything by -4. And the reason why I've divided it by -4 is because I want x coefficient to be positive. So that's going to be plus y minus 1. And that's your equation. So this is actually a linear equation. So that tells me that the path of P is a straight line. So the locus of P is a straight line. So anywhere on this straight line, the two distances between P, so P's moved up to here, PA and PB can be the same, so that's all it means. So that's question 1. Question 2, we'll start with another diagram.
So are we going to be ever asked to draw the line in the locus?
No, they just, the locus is like an equation, but the equation refers to sort of like the path that these two, that P, so P takes in order to fulfill these conditions. So the first condition is that these two lines are equidistant, or these 2 points are equidistant. So the next condition it has to fulfill is that APB is a right angle. So I'm plotting the two coordinates. So we want to say we put P here. So that's, this is what P is. P can obviously be up here as well. So I'm going to do a dashed line for P. We just need to find the locus where A, PB is right angles. So right angles refers to what?
Perpendicular.
Yeah, perpendicular, and also, so we want to show that PA is perpendicular. But how do we show that PA and PB are perpendicular though? They're gradients. So to show that PA and PB are perpendicular, we use that M plus. So whenever you see like 90 degrees of right angle, instantly you have to think of perpendicular and gradients. So they're keywords. So now what we'll do is find M1 and M2. So M1 is going to refer to PB. M1 is, let's say M1, gradient M1 is gradient PB, and the gradient M2 is going to be PA. So since P is variable, you're going to have two types of equations, or two algebraic expressions. Just to begin, Tilly, do you know what gradient is? No.
Just the solve for
No, just full gradient. So if you were to ever look for the gradient, it's always y2 minus y1 divided by x2 minus x1. Got it? So once again, it would be easy for us to assign, our coordinates is x2, x1. So x2, y2, x1, y1. Looking at this one, which one's easier? X2, y2. Okay, so what's the expression from P, the gradient of PB?
y2 minus 6
Yes. Okay. One at a time. Y minus 2 over. What about the expression for M? No. Expression for the gradient of PA?
Y minus 4 over x minus 1.
So we're referring to this sort of property here where if the two gradients are perpendicular, they should be.
So we times them together.
We times them together. To make it equal to -1. What I'm going to do here is I'm going to just do it as binomial expansion. times y minus 4, and the binomial expansion of that is y squared minus 6y plus 8. So I've just expanded that one, and binomial expansion for the denominator is going to be x squared plus 2x minus 3 equals to negative 1. And now, the last step is you're going to take the denominator and we're going to times it to the right hand side. So y squared minus 6y plus 8 equals negative x squared minus 2x plus 3. So I've just multiplied all 3 times to the other side. And now I'm going to try and collect, I'm just going to try and make all the terms on the left hand side. Okay, plus x squared. So all the x and y's are actually on the left hand side, and on the right hand side we're going to have the numbers. Right. Does anyone have any idea what this looks like? So, yeah, so this is the circle, so what we do is the last step is to complete the square. Trick? Big hint, you will have to do complete the square somewhere along the test. So you might as well practice this one now. So we know this is a circle because we've got x squared, we've got x, we've got y squared and y. That should be a big hint that it's a circle. So to do this, I'm going to do complete the square. So what do I add to y squared minus 6y's to make it a perfect square? Yeah? Oh, in blue is the thing I add. 9? Yeah, 9? Okay. What about 2x squared plus 2x? Do you reckon? Not 4, try again. 1? So whatever, so the ones in blue are actually our new terms, so whatever I added to the left hand side has to be added to the right hand side. So I'm going to add 9 and 1 to the right hand side. So I'm going to factorise this, that's going to be x minus 3 all squared. Factorise that. Sorry, that's y minus 3 all squared plus x plus 3 all squared. And this is going to be 5 plus 9 plus 1, which gives you 5. So it's a circle now. And what's the centre of the circle?
Holly, can I sacrifice Anthony and beat his double? Maybe so that's a whole question. Was the M equals y, so what one was that one?
M1 times M2.
No, the other one.
Just the 2 point gradient.
This one. And this is just the gradient here.
How did you prove that that was a right angle by making it a circle?
What we have to do is we're not proving it's a right angle. We're not proving it's a right angle. What we are doing is we're going to find the equation of the locus that makes it a right angle. We're not proving it's a right angle. It's given to us. It's a right angle. That's a condition. It's given to us.
So that's fine an equation of the circle.
Yeah, basically.
Anywhere on that circle,
Yeah. So if I was to draw the locus, if there's a circle, any circle. Oh my god, it's so ugly. But if I draw a circle, that has a centre at -1, 3, which is actually the other way around.
Yeah.
-1, 3.
Oh, you're breaking out.
I'm good at circle geometry, okay?
Maybe you're breaking my
Alright, year 12. Let's just finish this question. So if I drew a circle that had a centre at -1, 3 and a radius of √5, if I drew, say, a path point A, it will actually follow the circle. So this path will always ensure that these two are at right angles. So this path here is actually the locus. So basically that's what we're looking for. We're looking for the locus, the approaching the locus, which is the circle that ensures that these angles are always 90 degrees.